So today we are going to look at the second part of graphing rational functions, and we've got four major objectives. The first is continuing on with our concept of how to find slant asymptotes. The second is how do you find x-intercepts and y-intercepts. The third is how can we identify the range. And finally, putting all of these components together of rational functions and graphing them. So in class last, we talked about how to identify the horizontal asymptotes. And I introduced to you these three acronyms. The first was BOBO. And if the degree is bigger on the bottom, we know that the horizontal asymptote is y equals 0. All right. We also know that you could have the degree bigger on top, which would make the horizontal asymptote non-existent, essentially. It would be none. But we introduced the idea that if that's the case and there's no horizontal asymptote, there's going to be a slant asymptote instead. And we introduced the concept that a slant asymptote is found by either doing synthetic division or long division. And then the third possibility, when we were comparing degrees of the numerator and the denominator, is that the degree is the same. And therefore, our horizontal asymptote was found by writing the ratio of leading coefficients. So what I want to first focus on today is what happens if we don't have a horizontal asymptote and instead there's the possibility of a slant asymptote. So let's look at this first example. All right, we have y equals x squared minus 9 all over x plus 3. And what I want us to look at is if we looked at the degree of the numerator. Okay, if we looked at the degree of the numerator is 2. All right, and the degree of the denominator, which remember is the highest exponent, is 1. So this one falls into the category of Botten, all right, where the degree is bigger on top. The degree is bigger on top. So therefore, we can say our horizontal asymptote is none. But that means there's a slant asymptote. So how do we find that slant asymptote? Well, we do it by either completing synthetic division or long division. In this case, we can do synthetic division because our denominator or our divisor is in the x minus r form. All right, so essentially, this is x squared minus 9 divided by x plus 3. All right, so we're going to put negative 3 in the box, 1, 0, negative 9. And remember, this 0 came from the fact that this equation is missing that to the first degree, so we introduce it with 0x. All right, we're going to drop the 1. Negative 3 times 1 is negative 3. We're then going to add 0, negative 3. We get negative 3. Negative 3 times negative 3 is 9, and we get a remainder of 0. And so our slant asymptote is the equation left over. It's our quotient, and that's going to be 1x minus 3. All right, remember, our quotient is 1 power less than our dividend. Our power and our dividend is 2. So our quotient would have x to the first minus 3. All right. And if you were to graph that, that is the graph of a basic line. All right. So we would graph our slant asymptote. We would start at negative 3. And we'd go up 1 to the right one, up 1 to the right one, up 1 to the right one, and connect it with dotted lines because it's an asymptote. All right, so here we're putting multiple concepts together. So what I would like you to do is I would like you to identify the horizontal or slant asymptote from the next example. Y is equal to 4x squared plus x minus 3 all over 7x minus 1. Okay, so let's go through this one together. So this one here, if we looked at the degree of the numerator, it is 2. and the degree of the denominator is 1. Therefore, this 2 again is bigger on top, so there's no horizontal asymptote, all right, which means that there's a slant asymptote. Now, in this case, all right, we cannot do synthetic division because we are not in the x minus r form. So we're going to have to do long division for this one, all right? So if we remember, all right, we're only dealing with the first terms when we do long division. So 4x squared divided by 7x, and that becomes 4/7 x. So we put that here and multiply, and we get 4x squared minus 4/7 x. And then we subtract, and we get 11/7 x minus 3. Okay, when we drop down the 3. So 11/7 x divided by 7x is going to equal 11/49. So we have plus 11/49. And we can stop there because the remainder does not make any difference when graphing the slant asymptote. So the slant asymptote is y equals 4/7 x plus 11/49. And that's what you would graph if you were asked to do so. Okay, so now that we've spent time recognizing how to identify the horizontal asymptotes, how to graph the horizontal asymptotes, how to graph slant asymptotes and find them, we're going to talk about the next component. And the next component we need to talk about is identifying the x and the y intercepts. Now, to find the x-intercepts, after the function is simplified, you're going to set the numerator equal to 0 and solve for x. To find the y-intercepts, after the function is simplified, you're going to plug in 0 for x and solve for y. So let's look at this example. Let's find the x-intercepts and the y-intercepts of the following function. Now, as mentioned, you can't do this until the function is simplified. And remember, simplifying is always done by factoring. So we are going to factor the numerator, x plus 4 times x minus 3. And we are going to factor the denominator, and we get x minus 2, x plus 2. Okay? So now, in order to find the x-intercepts, you are going to set the numerator equal to 0. So our numerator is x plus 4, x minus 3. So our x-intercepts are going to be found by setting each factor equal to 0 in the numerator. And we get x equals -4 and x equals 3. And remember, the x-intercepts are points. So -4, 0, and 3, 0. Okay? Now to find the y-intercept, all right, we plug in 0 for x. So 0 plus 4 times 0 minus 3 all over 0 minus 2 times 0 plus 2. So we get 4 times -3 all over -2 times 2. So -12 over -4 equals 3. And so our y-intercept will be 0, 3. So once again, to find the x-intercepts, once you've factored and simplified your equation, you're going to set the numerator equal to 0 and solve. All right? In order to find the y-intercepts, you're going to plug in 0 for x and solve for y. You're going to do that now on this next example. All right? Y is equal to x plus 3 all over x squared minus 6x plus 5. Go ahead and find the x and y intercepts. Okay, so let's go through this problem together. All right, the first thing you're going to do is you are going to factor. All right, and you get x plus 3 all over x minus 5 times x minus 1. Now nothing can be simplified, so we're going to start with our x-intercept. To find our x-intercept, we set our numerator equal to 0. And we get x equals -3. So our x-intercept is -3, 0. To find our y-intercept, okay, we are going to plug in 0 for every x. And we get 3 over -5 times -1. And so we get 3/5. So our y-intercept is 0, 3/5. Okay, so now we've spent all this time finding all the components of rational functions. We've learned how to find the domain. We've learned how to find all the discontinuities and how to graph the vertical asymptotes versus the holes. We've learned how to identify the horizontal asymptotes along with the slant asymptotes, and now the x and the y-intercepts. So by doing that, we now have all the building blocks to graph a rational function. And within graphing of a rational function, you will be able to determine how to find the range. So these are the 7 steps you are going to want to follow. The first thing you are always going to do is find the horizontal asymptote and or the slant asymptote and graph it. Then the next thing you're going to want to do is factor. Once factored, you're going to identify the discontinuities based off of the limitation of the denominator. So those limitations will help us find the domain. Once we do that, we are going to identify whether those limitations are a hole or a vertical asymptote by simplifying the function. And then we're going to graph the horizontal asymptote or the slant asymptote, the vertical asymptote or the hole, and then we're going to move on and find the x and y intercepts like we just did and graph those. Finally, we're going to use our graphing calculator to fill in the rest of the graph. And by looking at the graph, you're going to identify the range. So let's do this first example together. Let's graph y is equal to x squared minus 1. So the first thing you're going to do is identify whether it has a horizontal asymptote or whether it has a slant asymptote. So we're going to look here and we're going to say, all right, the degree of the numerator is 2. The degree of the denominator is 1. So we have bottom here, bigger on top. So there is no horizontal asymptote. But therefore, we have a slant asymptote. So we can do synthetic division here. All right. Not really, though, because we don't have an R value. So we're going to do long. Okay, we're going to do long division. X divided into x squared plus 0x minus 1. So we're going to do x squared divided by x is equal to x. So I'm going to put that here, and I'm going to multiply it. We get x squared. And I'm going to subtract that, and I'm going to bring down 0x. All right, well, we know that that's going to be 0. So we're bring down -1, and that's not going to be possible, so that's our remainder. So remainder 1. So our slant asymptote, and if we remember, has nothing to do with the remainder. Okay, so that essentially gets canceled out. We don't care about it. So our slant asymptote has the equation y equals x. So I'm going to graph that. Okay, we have a y-intercept of 0, 0, and then we go up 1 to the right 1, up 1 to the right 1. All right, and we're going to graph that. All right, great. And we're going to go like this. And there is our slant asymptote. All right, so step 2 requires us to factor. So here the only thing that's factorable is the numerator, x minus 1, x plus 1, all over x. Okay, so now we're in simplified form. So step 3 is identify the limitations. Well, there's only one x in the denominator, so we set that equal to 0. X can't equal 0. So we can find our domain here. Our domain is going to be -infinity to 0 and 0 to positive infinity. Okay? Now, that limitation cannot be canceled out. So we know that 2 is our vertical asymptote. X equals 0 is our vertical asymptote. So we're going to come and we're going to graph that, and it's going to look like this. So step 5 requires us to find the x and the y intercepts and graph them. So to find the x-intercepts, all right, we set the numerator equal to 0. So x minus 1, x plus 1. So we'll get x equals 1 and negative 1. So our x-intercepts are the 2 points, 1, 0, and negative 1, 0. So we can graph those, 1, 0, and negative 1, 0. Okay? And then to find the y-intercepts, we're supposed to plug in 0 for x. But when we do that, we get 0 in the denominator. This is not possible, so there is no y-intercept. Okay? So there we go. So now we're going to plug it into our calculator and copy the graph. And it will look just like this. And this makes sense because as an asymptote, you can approach it, but never cross it. And there are all your components of a rational function. Now, the last thing you have to do is identify the range. All right, you have to identify the range. And once again, identifying the range can only be done by looking at the graph. Well, if we look from top to bottom, all of the y values are going to be included in this graph. So our range is going to be negative infinity to positive infinity. Now it's your turn to do one on your own. The equation is y is equal to x plus 6 all over x squared plus x minus 6. Go ahead and find all the components of the graph, answer the questions, and graph it out. Okay, so the first thing we're going to do is determine whether we have a horizontal asymptote or slant. So the degree of the numerator is 1. The degree of the denominator is 2. So this is bigger on bottom, which means that our horizontal asymptote is at y equals 0. So we can automatically graph that right here. All right, so that's step 1. Step 2, we're going to factor. Here, all we can do is factor the denominator to x plus 3 times x minus 2. Okay, so step 3 is state the limitations. So x plus 3 cannot equal 0. X minus 2 cannot equal 0. So x cannot equal negative 3. X cannot equal 2, which means that our domain will be negative infinity to negative 3, and negative 3 to 2, and 2 to positive infinity. Okay? Step 4 is to identify what those limitations are, because neither of them can cancel out. X equals negative 3 and x equals 2 are both vertical asymptotes. So I can go in here at negative 3 and graph this out, and at x equals 2, graph this out. So now we have to find the x and the y intercepts, okay, for step 5. So to find the x-intercept, we set the numerator equal to 0. So we get x equals negative 6. So we know our x-intercept is negative 6, 0. Okay, and then to find our y-intercepts, all right, we are going to plug in 0 for x. So 0 plus 6 over 0 plus 3 times 0 minus 2. So we get 6 over negative 6 equals negative 1. And we would plot that there. 0, negative 1 as our y-intercept. So finally, we're going to plug this into our calculator. And it's going to look something like this. Let's try that again. Let's do it in a different color. And there we go. There's the graph of your rational function. The last thing you would have to identify here would be your range. When looking at your range here, all right, you're looking at what y values it can't equal. All right, so what's interesting about this is that there's a little gap somewhere between -1 and 0. And so for now, we're just going to go like this. From -infinity to 0 and 0 to +infinity. Alrighty, that is it for today. I will see you guys in class.